Okay, hello Cloud Gurus, how y'all doing? My name's Scott Pletcher, and welcome to our little series, DeepRacer, the Fast and the Curious. In this episode, we are going to learn all about hyperparameters and how we can use them to really fine-tune our training process. Tune, get it? Get it? In episode number 3, we talked about the Markov decision process and the concept of a reward function. But the Markov decision process has some other elements as well, and we can control those, which has an impact on the training process. For starters, we have our choice of environment. We can choose different tracks, and different tracks will provide different experiences for the training process, thus creating different abilities for our model. We also have our choice of action space. We can choose the speed and steering options that we present to the agent in the environment. That also influences the training process and develops different abilities. We also have hyperparameters, and you can kind of think of those as dials and knobs that we can use to adjust the training process. It's kind of like a sound engineer in a sound studio in front of a giant mixing board. Now, to get the best sound, sometimes the audio engineer has to adjust for the room, the instruments, or the artist. Same goes for reinforcement learning. Now, if you recall, the car, our agent, is in its environment, the track in our case. Now, the thing we're trying to train, the policy, will take an image from the onboard camera, in this case it's a simulation, and try to decide what action to do next. Once the car selects an action, everything gets sent through the reward function to give us some sort of reward. Now, the training process keeps up with this reward, as well as the observation, the state, and the action taken. And it kind of writes it into a little journal. Now, this whole process is called an episode. And these episodes repeat until we have a nice set of data on which to train. And this brings us to our first hyperparameter, the number of episodes. It's sort of like how many pages in our journal we're going to amass before handing over the whole book to the policy update process. The more episodes, the more data the policy update process has to go on. But more episodes also mean a longer duration for training. Now, when we hand over our journal, or experience buffer as it's known, to the reinforcement learning algorithm, the first thing the algorithm does is take a random sampling of the data inside that journal and group it into batches. And we can define how large we want those batches using the batch size hyperparameter. And larger batch sizes mean more stable learning, but it also slows down the learning process. With our subset of experiences now in batches, the reinforcement learning algorithm will churn through those batches, usually several times, and yep, there's a hyperparameter for that. One pass over the batches is called an epoch, and we can define how many times we want to allow the algorithm to go over those batches. The more times, the more stable the updates will be. But as is becoming a common theme, it's going to slow down the learning process. Now, as the algorithm is working through those epochs, lots of heavy-duty number crunching is happening. The algorithm doesn't just look at any given step and the associated reward, it tries to look into the future to see anticipated cumulative reward based on that action. And we can control how far into the future the algorithm looks by something called the discount factor. If we use a discount factor of 0.9, the process is going to try to look 10 steps into the future. If we use 0.999, it's going to look 1,000 steps into the future. Well, when we're trying to learn something new, sometimes looking too far into the future can just be unnecessarily overwhelming and complex. Same goes for the reinforcement learning process. We don't want to look too far into the future unless we're sure it's going to result in some equivalent benefit for us. While evaluating all these factors, we need some way to figure out if we're headed in the right direction. And we call this a loss function. Now with DeepRacer, we have our choice of two loss functions, one called mean square error, the other called Huber loss. Now, both of them perform pretty much the same in the early parts of training, but Huber loss tends to be more subtle as training goes on. I like to think of Huber loss as a tiny little hammer, whereas mean square error is a big hammer. Both of them will get the job done, but one might take a little longer, while the other one might be too aggressive. Now that we've analyzed the experiences and via our loss function, we think we're headed in the right direction to make some improvements to our policy. The problem is, are we 100% sure that there's not a better way out there? We probably want to encourage our model to explore the world more in case there's something better out there. And in reinforcement learning, we call this entropy, and it manages the so-called trade-off between exploit and explore. Now we can encourage our model to try different things by sprinkling a little bit of randomness on the policy updates. And we can control the amount of delicious random sprinkles by a hyperparameter called entropy. And entropy is just another word for randomness. Okay, now we have the collection of improvements that we want to make to our model, the weights for our neural network layers. Now, we don't want to make these changes too drastic because we risk overshooting a perfect model. On the flip side, if we just make little tiny adjustments, it can take forever to get a decent model. So we can control the amount of change using something called the learning rate. Do we take little tiny steps, big steps, or somewhere in between? Now that our policy has hopefully been improved based on our last iteration, we send it back into the simulator for another go-round. And around we go until our time runs out. The one last factor we have to influence the training process is time. How long should you train your model? That is a very good question, and I have a very bad answer. It depends on lots of things. I usually train my models in 1 hour increments. After that, I'll check the reward function graph, maybe do an evaluation. If I think I'm on the right track, I'll make some adjustments and train for another hour, and so on. None of my top 10 models trained over 4 hours, so you definitely don't need to train for hundreds of hours to be competitive. Speaking of being competitive, AWS reInvent is only a couple months away, but you still have plenty of time to win some cool prizes and maybe even a ticket to reInvent out on the DeepRacer Virtual League. So go put all this new knowledge to good use.
Now, if you're super keen about machine learning and want to learn more, go check out our Certified Machine Learning Specialty course, only available on the ACLAD Guru platform, where Scott and Brock will teach you everything you need to know about machine learning.
Until next time, keep learning and keep being awesome, Cloud Gurus.